So Dr. Anurag Mishra, can you just have your on the board?
Yeah. Is my slide visible, sir?
Yeah, we can see.
Right. Thank you so much, sir. Good evening, ladies and gentlemen. Greetings and regards from the land of Lord Jagannath. Gratitude, Arup sir, AIOS, for the platform, and Arul sir in particular for giving me a cue. We are going to pick up from where you left, sir. I do work with the industry, ladies and gentlemen, but none of that has got any influence or any bias in this talk in particular. The ultrasonic biometer has done a pretty reasonable job for all of us, but there were a few aspects which needed special emphasis. We did falter on the issue of accuracy. We wanted to measure more number of parameters and wanted to measure them accurately to essentially predict the elusive ELP, which were required for the modern day formula. So the answer was technology giving us optical biometers, and they work on different technologies. Let's just peep into them before we proceed further. The first optical biometer that was launched into the market worked on the principle of partial coherence interferometry that was incorporated into the IOL Master and then on the IOL Master 500. It utilized a light source which was multimodal. It has a flickering wavelength, the max reaching up to 780 nanometers. When it comes from the light source, it gets differentiated by a beam splitter into a moving and a split mirror. Both the light beams enter the eye. Both the light beams get reflected by another fixed mirror to be caught by an interferometer. The waves come into phase at a certain given point in time where they're coaxed and produce what is known as a constructive interference. Now, apart from this, the IOL Master 500 also had an interesting concept built into it. These are the wave patterns that are produced by an optical media which is opaque, very bizarre. So what it did was it differentiated between signal, which was generated by the eye, and noise, which was generated by the optical media, which was opaque, and also the machine due to irregular refraction of light. It escalated the signal, accepted the signal, discarded the noise, producing a higher signal to noise ratio, and then produce a uniform curve with a single peak. We would get a clearer picture in this GIF. Just keep an eye on the right-hand side column out here. When we start measuring and the number of measurements increase from 0 to 20, the bizarre waveforms give rise to a single rising in height Manhattan, and the signal to noise ratio also is increasing to pretty much acceptable levels. The IOL Master 500 gave us different readings in terms of keratometry. The axiometry was pretty much accurate, coming into within 100 microns of accuracy, but the keratometry was little faulty. The anterior chamber depth was based on slit beam reflectometry and not really a proper measurement. The white to white also had a little aspect to be desired. To correct all these, the next technology was launched, which was the optical low coherence reflectometry used by the High-Stride Lenstar LS900. It produces a light wave. It's produced by a light wave, which is 820 nanometers in wavelength. So expectedly, the penetration would have been better. The light wave that enters the eye and gets reflected back is compared with a reference optical beam that is already incorporated in the machine. This reference optical beam undergoes a Fourier transformation, and then both the light beams that come from the eye and the reference are matched with. They produce a uniform A scan right from the cornea to the retina. So almost any point to any point can be measured. It gives us the lens thickness, the anterior chamber depth, and the light source that is there is the superluminescent diode, which has a constant spectrum in contrast to the flickering frequency of the IOL Master 500. But there were features that were faulty with this technology as well. This did not have the composite signal technology as the IOL Master 500 had, so it had difficulty in penetrating, particularly a dense sheet of posterior subcapsular cataract. To address to all that, the final technology was launched, which was the swept source OCT. It utilizes a light source which has a wavelength mean of 1060, but the wavelength sweeps across 1050 to 1070. That's from where it derives its name of swept source, actually, with the mean being at 1060. It has a single fixed mirror. Both the light rays again enter the eye and get reflected back into a photodetector device. The IOL Master 700, which utilizes this SSOCT principle, gives us a continuous B-scan image like this right from the cornea till the foveal pit. It scans the eye in 6 radial meridians lined at 0, 30, 60, 90, 120, and 150. 128 scans are taken along each of these meridians, and the whole measurement is repeated 5 times. So that's amounts to 2,000 scans per second. It gives us a very accurate anterior chamber depth. In fact, it also gives us an AQD, which is the distance between the endothelium of the cornea and the anterior lens capsule. Comes in very handy when we are planning a phakic IOL. It gives us an axial length. It gives us the central corneal thickness, pachymetry, and it also gives us the lens thickness. So all these measurements are possible with the SSOCT. What is also possible is that we can see from where the measurement has been taken. If we can see a foveal pit clearly, then the measurement is to be taken. If we cannot see the foveal pit clearly, then the measurement should be discarded. So for the measurements to be accepted, we have to have the subsequent measurements, and the measurements should yield an axiometry within 30 microns of standard deviation. The keratometry should yield at values within 0.05D. Fixation on tracking should be proper and should have an echo-free vitreous. Now let's go to my clinical biometry workflow. I have 4 workstations for the patient to travel from one station to the other. This starts with the IOL Master 700. As we talked about, it produces 2000 scans per second. It penetrates the dense cataracts because it has a 1060 nanometers light source. The measurements are all telecentric because telecentric, the advantage is if the machine does take a reading, if the machine doesn't take a reading, it's different. But if the machine does take a reading, it's not dependent on the distance between the eye and the machine's eyepiece or objective lens. So if the machine takes a reading, then it is usually accurate irrespective of the distance. So that negates some sort of user influence. It gives us the opportunity to do a fixation check. And there is an inbuilt algorithm for silicone oil filled eyes and post laser vision correction, as we would see in a moment. The next station the patients have to go to is an eye trace, which has a proprietary ray tracing technology. It gives us both wave front and sim case. The higher order aberrations, angle kappa and alpha, the offshoot axis are calculated accurately. Pupillometry in all circumstances can be calculated. It gives us a tracy refraction, which is very interesting. This is a refraction which is calculated at the pupillary plane or at the anterior lens capsule plane. So even if you don't measure the posterior cornea, you can get a fair bit of idea of its contribution to the manifest astigmatism. It gives us a modulation transfer function curve based on the reading of which we can decide whether the contrast sensitivity is already reduced and whether the candidate is a good candidate to receive a multifocal implant. And finally, there's an Osher's alignment check. Should you go wrong with a toric implant, you can always go and cross-check that in the post-operative period. The next workstation in my setup is the image-guided variant system. It gives us a keratometry based on 12 LED lights arranged in a single ring, but there's a certain amount of dynamism that is associated with this keratometry. Before the instrument comes to a focus, the 3 infrared lights actually map the corneal curvature as well. So it gives us very dynamic keratometry. It has an excellent planning cockpit in terms of the exact residual refraction that the patient is likely to land up with after the cataract surgery is done. It can enable you to give an on-axis incision. I'm an on-axis surgeon myself. And of course, the system is markerless. And finally, combining all these platforms, the new warrior that has descended on the Western Front is the Heidelberg Engineering's equipment called Anterion, which the patient has to go through in my setup for the final testing. It combines both stress source OCT and ray tracing technologies. It is a tomographer, however, you can take in the central corneal readings as well. 16,000 data points are analyzed before giving you the keratometry in this case, and all those are OCT pieces. So they claim that it is independent of the integrity of tear film, and we have more than one observations to prove this claim as well. But it does give you a blinker on the side of the screen that the tear film is not integral. So I'm not saying that you shouldn't treat the ocular surface condition, but at least it is independent of the integrity of the tear film. It has the best penetration in the form of the light source, which has 1300 nanometers of wavelength, and it gives excellent high definition imagery of the anterior segment, as we'll see in a while. Coming to the measurements, when it comes to the keratometry, I always take the anterior readings. Most of these equipments are in agreement with each other for most of the patients, but should there be a disagreement for the keratometry, the order for me is always anterior followed by variant, and then finally IOL Master 700 and eye trace. For the axiometry, it is anterior and IOL Master. Both of them perform reasonably well and quite equitable. For the higher order aberrations, the eye trace, of course, is one of the best equipments in the world. The anterior also does a pretty reasonable job with that. And for the offshoot of axis, the measurements are given by the measurements are given by, the measurements are given by eye trace in terms of value and vector. The anterior also gives us a measurement of the same. But the Varian and the IOL Master, they give sometimes give faulty ratings. The Varian, in fact, gives you just markers from where you can get a fair bit of idea, but it doesn't give you any measurement at all. So let's look at certain clinical applications. This is one example wherein the difference between two subsequent measurements is 10 microns in terms of axial length and 0.02 diopters in keratometry. So this is one reading which you can accept vis-a-vis the next reading wherein it shows 190 microns difference in the axiometry and 0.5 diopters difference in keratometry. This sort of reading should be discarded. This is one example wherein I had missed something clinically. My optometrist came running to me and said, I find something in the B-scan image of the IOLmaster 700. Please cross-check. We did an OCT and found that there was an ERM pulling on the macula. I had missed it clinically. Call it my negligence, but I had missed it. There's another clinical miss by me in one of the other patients, which the optometrist brought to my notice and showed this. We did an OCT and found similar pictures in the OCT at the macula. This patient should have landed up in disastrous outcomes post-operatively had we missed these findings brought to my notice by the enigma of the posterior polar cataract. It's a central, densely sitting plaque, so the light rays often do not penetrate through it. But the anterions, this is the anterion reading. The anterion's excellent wavelength actually does that and gives us all the readings that we require from the machine. And it also gives us an anterior segment picture like this, where you can see the plaque and you cannot see a broad daylight passing through between the plaque and the posterior capsule. So these are instances where the posterior capsule is likely to be involved in the plaque, so we should be very careful while handling them in the OT. The lens tilt sometimes corrects the toricity of the cornea, sometimes augments the toricity of the cornea. This should be found out. This is an IOLmaster 700 picture, and you can see the tilt here. But the fixation check will tell you that the fixation has been proper. So this tilt that is shown in the B-scan image has not been due to a fixation lost by the patient. We can know that. So there is a lens tilt. The other method to find it out also comes from the anterior. As we can see, the light passing through the corneal vortex is shaded green, but the lens axis is shaded yellow, which is based on the lens vault. So they are not in agreement out here. So they vary from each other. The lens tilt can also be found out with the eye trace. This was one patient wherein we had attempted, or the variant showed us a T2 to be implanted in this patient, but when we subjected the patient to eye trace reading, as you can see on the internal plane, all the higher order aberrations are grossly elevated. The cornea is doing fine, but the internal plane, all the higher order aberrations are elevated. This happens when there is a lens tilt. So we went back and decided against putting in a toric implant in this particular case. This is a case wherein there was a hypermature Morgagnian cataract, and you can see the OCT imagery of the anterior, which is very clear. It has taken the whole lens slice. The lens thickness is grossly increased to 4.53 millimeters. So if you're planning a femto in this particular patient, we have to make sure we have to mentally imagine that the nucleotomy at least is not going to travel till the posterior plate. So we have to manually fracture it inside the OT.
Anurag, I think we have to keep an eye on the time.
Yes, sir. Okay. This is my last slide.
Yeah.
This is my last slide. So the silicone oil filled eye also has, this is a vitreous body. Keep an eye on the IOL power calculated is plus 19, but when you switch over to silicone oil mode with the same machine, if you just switch over to the silicone oil mode, the machine auto calculates this, and plus 22 is the the diopter that comes in, which is pretty equitable with the other eye, which also shows a plus 22 for the same IOL. So the silicone oil mode and the post laser vision correction mode are also incorporated in the 700, which give us accurate readings in these circumstances. Thank you so much, ladies and gentlemen, for the kind attention. Thank you for the opportunity.
Thank you, Anurag. And